So if you're building anything with AI right now, you know exactly what I'm talking about. It can feel like this delicate balancing act, right? You're trying to connect all these different tools and models to create something that's smooth and reliable. Well, today, we're going to dive into the one concept that makes all of this possible: AI orchestration.
At its heart, orchestration is all about this really simple but super powerful idea. It's the art of being the glue, taking all the separate pieces of your AI app, the language models, the APIs you're calling, your own business logic, and just binding them together so they actually work as one solid application.
And that's the real question, isn't it? Because in the real world, things break all the time. APIs go down, models spit out weird formats, networks get laggy, and when that happens, that beautiful application you designed, well, it can just fall apart in an instant.
And that gets us to the absolute core problem that every single AI builder is facing: this idea of creating brittle systems. Systems that work perfectly when everything is going right, but just completely break down at the first sign of trouble.
Okay, so let's look at a super basic workflow. We can call this the happy path. A user makes a request, we call a language model, and then we format the output. Simple, clean, and honestly, in a perfect world, this is all you'd ever need. But now, look at this. This slide shows you just how fragile that happy path really is. A single, tiny, temporary error when you call that API, and the whole process just stops dead in its tracks. That final step? It's never even reached. Your user gets nothing but an error message, or maybe even worse, just a spinning wheel that never resolves.
So here's the key takeaway. The more complex your AI application gets, the more places it can break. Every new tool, every new API call you add is just another link in the chain that can snap. This is why we need a totally new approach. We have to move away from building these simple, fragile chains and start thinking more like a conductor, managing a whole orchestra of different services. And that is the core idea behind AI orchestration. So if we're going to put a formal definition on it, this is what we're talking about. It's not just about hooking up step A to B to C. No, it's a dedicated engineering discipline. It's all about building in the intelligence to handle errors, to manage different tools, and to create something that's truly ready for production.
The conductor doesn't play every instrument, right? But they make sure every section comes in on time and plays in harmony. And if one musician hits a wrong note, the whole performance doesn't just collapse. The system is resilient. It knows how to recover.
Okay, so if orchestration is the conductor, what are the actual musical notes? What are the core mechanics that give us this reliability we're talking about? Let's break them down.
These are the fundamentals, and getting these right is key. You need to manage state, always knowing where you are in the process. Branching lets you build in logic, like if the AI says this, go here. Timeouts are crucial. They stop one slow API from freezing up your entire system. And item potency. Okay, this one is huge. It basically means running a step multiple times has the same result as running it once. Think about charging a credit card. You have to be sure a retry won't charge someone twice. Then you've got observability to see what's going on. And of course, your first line of defense, retries.
Let's just double down on this one for a second, because it is your absolute first line of defense. So many errors out there are just temporary glitches. An API is down for a second. A network connection blips. A simple automatic retry can solve a massive percentage of these problems without anyone ever knowing something went wrong. All right, now that we have the building blocks, how do we actually structure them? Well, there are two main ways that people build these things today, and you gotta understand the trade-offs.
On one side, you've got chains. They're totally linear. A, then B, then C. They're great for simple stuff because you can prototype them really fast. But man, they can get rigid and become a nightmare to debug. On the other side, you have graphs or state machines. These are way more dynamic. They can handle loops, complex branching logic, the whole shebang. The trade-off? Yeah, they can take a bit more work to set up. But for any serious production-level AI application, you're pretty much always going to end up working with graphs.
So, enough with the theory. Let's make this less abstract. What does a properly orchestrated, real-world workflow actually look like? Here's a perfect, practical example. It's a 4-stage process. First, you intake some data, like a user asking to summarize their last 3 support tickets. Second, you enrich that data. You go call your database API to actually get those tickets. Third, you act on it, sending all that info to an LLM to generate the summary. And finally, and this is crucial, you have a QA step to check the output before it goes anywhere. And that QA step is where orchestration really shows its power. It doesn't have to be automated.
A really well-designed system lets you pause the entire workflow and insert a human in the loop. This is a checkpoint where a real person can approve, deny, or even edit what the AI did. For anything high stakes, this is absolutely essential.
So, as we start to wrap this all up, what's the single most important mindset you need to have when you're building these systems? Well, it all comes down to one golden rule.
This is it. Stop trying to build systems that will never, ever fail. It's impossible. Instead, build systems that assume failure is going to happen and know exactly what to do when it does.
And this is how you do it. You put in those smart retries we just talked about. You set clear guardrails and timeouts so a broken process doesn't run forever, costing you a ton of money. And you regularly audit your system to find the weak spots before they break on a real user.
So I'll leave you with this question to think about for your own projects. Are you just building for the happy path, kind of hoping everything goes right? Or are you designing a robust, orchestrated system that is fundamentally engineered to handle failure? Because honestly, the difference between those two approaches, that's the difference between a cool prototype and a real production-ready AI application.